Hey YouTube, Jay Kilroy here. I guess you could call this Fogless Coolant Mr. Number 4. Been playing around a bunch, trying all sorts of different things. Lots of suggestions online. I want to thank everybody that's made suggestions. Too many to name, but let me tell you, I've tried a bunch of them, and I'm here to report on some of them were good, some of them not so good. And I hopefully will be able to tell you why. I'm working on the switch, getting a switch to control the solenoids. I want something from the front of the machine like we talked about. And I've got these Allen Bradley switch housings. I've got 3 of these things. I bought them off eBay ages ago, and one of them is used on the mill currently to have my direction, stop, and start buttons. And I want to expand that. And I could just buy one of these boxes that has additional holes in it, but these things are ridiculously expensive. They're really high dollar new. And I happen to still have 3 of them. So what we're going to work on today, besides just reviewing what's going on with the misting system, is we're going to join 2 of these up so that they make one box with 6 holes instead of individual units. Let me get the camera, get over here and show you how I'm set up now, and the upside, the downside. We'll discuss some of the things that I've learned. Maybe you don't have to learn them the same way I did, which in some cases involve somewhat mess. So give me just a sec. Okay, here we are. Now, if you remember from the last video, I had consolidated my air lines in here to a regulator, came off a T. I got rid of my secondary regulator. You'll notice it's back, and then I went to a solenoid for the air, and then the solenoid went out, controlled airflow to the nozzle. And I didn't have anything here. Well, someone suggested, I don't remember the gentleman's name, but suggested that I put a solenoid on the coolant side. It's presently right here. Now, I've tried it right here. I also tried it right here. And I also tried it right here. And all 3 of them have a similar problem. What happens is, when you, let me depressurize this just a second. Okay, what I'm going to do here is I'm going to depressurize the system, which is basically the same as taking air off the input side here. What I did is I've just got my air gun plugged into the bottom of this drop that feeds this whole setup. And I want you to watch the air tank, the coolant tank. Do you see there's a lot of volume tied up in here in terms of pressurized area, the amount of pressurized air in here. And then, even though the liquid doesn't pressurize, the output side here of the hose stretches. This stuff stretches when it's under pressure. So what happens under this current situation, let's pressurize it back up. When you pressurize it, you see the water level, coolant level in here will drop about a ½ inch. So then we're going to turn the solenoid on to get airflow and coolant flow. Now here we are. The coolant's off at the needle valve. So now I'm going to turn the coolant on. I'm just going to barely turn it back to where you can't even really see the coolant, but let's get a little flow going here. So we got coolant flowing. Now I'm going to just I'm going to leave everything the way it is. The idea is that I could flip this switch, cut off the solenoid, and everything should stop without having to actually turn this needle valve. I could just flip a switch. Let's watch and see what happens. We got to move kind of quickly here. Click. See, it's kind of a mess there. What's happening here is that this hose is stretched. It's full of coolant, and it is stretched out under the whatever 20 to 25 psi of pressure, pressurizing the coolant side. When you shut this solenoid here, pressure still exists in this hose. Okay, the needle valve is still open. I haven't adjusted the needle valve, right? So when you close that solenoid and cut off this air pressure, the pressure built up in the hose, the stretching of this polyurethane hose, only has one place to go. It can't flow back in through here because this solenoid's closed. So it's going to make a mess and flow out through here. Now what happens when you turn the thing on, back on? Listen very carefully. Okay, you get a really nice big goop that shoots out when you first turn it on. I'm going to shut the needle valve off there. So this has been marginally successful. I think I liked it better. The reason I had to put this back in here, this pressure regulator, was that when I put this second solenoid in, before this second solenoid was in and before this was in, I had just this one regulator, air coming out, and the air and the fluid were pressurized to the exact same pressure by this one regulator. When I put this solenoid in place, this provided enough restriction to the fluid flow that then when I pressurized the systems the same, the air here was actually exhibiting slightly more potential than the fluid, and it wasn't actually allowing the coolant to flow into the system at all. It was actually backfeeding and pushing the coolant back through the system back into the tank. So that wasn't usable. So I had to put a second regulator back into the system, this regulator here, back into the system so that I could regulate my air separately than my fluid, which right now the fluid's regulated to 20 psi, the air is regulated to 15 psi. So it works, but you still have to cut off the needle valve. So I think this was a lot of complication for not a lot of gain. I'm going to go back to, I'm going to get rid of this solenoid, take this back off. I'm going to take this other regulator back out, and I'm going to simplify the system back to where it was and just leave it like that, because that worked every bit as good as this and was a lot less complicated. I will say that having the second regulator does give you more flexibility to adjust your flows, your air versus, obviously your air versus your coolant flow, and gives you a little more control, but I just don't know that I'm going to mess with it all that much. So anyway, here's the switch box I was telling you about. Here is my current direction, stop, and start switch. I want this switch, I want the solenoids to be tied in to my stop switch, so that when I press my stop switch, this is also a viewer idea, when I press my stop switch like so, that the solenoid, the air solenoid would be closed at that time. And I want to have it basically mounted here so that I have 6 spots that I can mount switches in. So and that's what we're going to do. So let's get back over here. Alright, got my piece of aluminum cut here. I didn't go across the street, nobody was at the shop, so I cut it on my bandsaw, cleaned it up a little bit with the file, cleaned the cut edge up a little bit with the file. Anyway, I got the pieces laid up here, and I got a set of transfer punches out. I didn't measure that hole, but got them lined up. I used the edge of my square here to get them lined up straight on the piece. And what I'm going to do now is just drop this through here and very lightly point down, Kilroy. Very lightly tap these. I don't want to shake them around. I just want to make a little indentation that I can pick up after I move the blocks. Alright. There we go. And let's grab a center punch and put a little wang dang doodle. Technical term. Alright, not really worried about this hole here. Be in the back, won't be seen. Not really concerned. Anyway, so there we go. Plates cut. Got all the holes laid out to drop these up here, mount them in such a way. We got to figure out what size fastener goes through this hole, and choose us out a clearance drill size. Alright, we are hooked up. We're going to try a test run here. Got my holes drilled. It's a size 10. It's a size 10 fastener that goes through that hole. One thing interesting is the bottom of these enclosures are extremely thick. So it's you have to have a surprisingly long fastener to get through the bottom of the box. Right. All right. It's looking like that's going to work out really well in terms of mounting goes. A couple of these screws in here. So there we go. The screws aren't bolted down, nothing's tightened up here tight, but so the next thing to do is we're going to cut a passageway between these two housings so that I have a way to handle wires back and forth. Alright, here we go. We're on the machine. This is aluminum. So I'm going to spray with WD-40 as a lube. So again, we're in back gear. Pretty low RPM. We're just going to peck away here. All right, we're through. It's not a flat surface here. It's sloped, so we were cutting in at an angle, so I took it very, very gently. I didn't want to pretzel the box or anything. So I'll get the vacuum going. So there we go. Hole number one. It's a 1 7/16 hole, by the way. So let's get the other one mounted up. So I put a mark in here so I wouldn't forget where I was going. Because, well, you know, well, getting old sucks. Okay, now what I need to do is I need to measure, since it's not symmetrical here. I'm going to take my hook scale. I'm going to measure this distance right here. 3/8 of an inch. Oops, excuse me, 3/8 of an inch. So I'm going to space this. This is taken care of. So now I'm just going to space 3/8 of an inch up from the face here. Okay. There we go. 3/8 of an inch. Let's double check my measurement, make sure I don't fugazi this up. 3/8 of an inch. Okay. Fire in the hole, cut number 2. Alright, there you go. Let's sweep all this away here. Get this out. Ugh. Nasty mess. Let's see if I can hold this up in such a way that you can see what we got. There we go. So we got a nice passage hole, box to box, for the wires to go. Let me clean this up and get back with you. Alright. Got one of the boxes mounted to our plate here. Some little, number 10 size socket cap screws and some little nylock nuts here on the back. And got my holes drilled. They line up quite nicely. Done a little deburring in the hole there. I'll do a little more deburring in the hole. I just don't want to. I don't want to cut a wire because the hole's too sharp. Alright. So what I'm going to do now is I've bolted this one down firmly. I've test fit this one up here and make sure it fits in nice and tight. So what I'm going to do now is I'm going to get some good old-fashioned RTV Ultra Black here. I've cleaned this off with a little to get rid of the oil from the cutting process. Put a little RTV on there. And then I'm going to mate these babies up and bolt her down. So I've misplaced a fastener. No, I haven't. There it is. All right. There's no reason to really snug down those bottom two quite yet, because these bottom two down here are the bolts that go through the case and hold it to the mount on the mill. So we're going to go ahead and head over there and get this mounted up. Alrighty, this is the last of the screws. We got our double box mounted up here. And I just wanted, before I put the other cover on, I wanted to go ahead and give it a run, make sure everything's working okay. Flip our disconnect back on. Everything's looking good. So there we go. And a couple things for my good buddy Tom Lipton at Ox Tools. That neat little boss you were talking about actually exists on my machine too. You know, I've never noticed that before. Of course, there's no knob in it. I'll have to make a neat little knob to go in there. But yeah, the little boss does exist on my machine. And then I've got one other thing for you, but we're going to have to do a little walking to get there. So let me take you somewhere.
Sit in my office and do the calculator, run the calculator.
Okay, Tom. I know you thought you had a manly fan, but you do not. Your fan is a wimp. Pardon me while I turn this up. I'm having to stand back here so it doesn't roll away. There you go. I win the biggest fan competition.